Thanks, Gary. So, just got a couple of projects that we've been involved in at Novartis to present to you this morning. One is following on directly from the work that Gary's been doing with the Nimmitabel strain of seromazine resistant fly. But also the second project that we've been looking at is trying to get an idea of the prevalence of anthelmintic resistance on Australian sheep farms and a really up-to-date snapshot of what drenches are working and what drenches sadly aren't. When we think about the theme of today's presentations, it's efficiency of productivity, and I would argue that it doesn't matter the quality of the feed that you put in front of sheep or how well you manage them from a husbandry perspective. If we don't control internal and external parasites, that's really going to make all of that a moot point. If we think about the cost of these parasites in terms of production, and Rob will certainly discuss this in his talk, but the difference between treating a sheep with a fully effective anthelmintic and an anthelmintic that's working at about 85%, which some would consider would be quite a good number, was found in a study to be about $16 a head based on today's prices in terms of lost productivity in wool and growth. And that's pretty staggering. In terms of flystrike, similar studies were done to look at the cost of a single untreated, what we would call a covert strike, that's not really noticed by the producer. It's the kind of strikes that you might see when you shear the sheep and you just notice a small strike there. Based on today's prices, a single strike like that in terms of cost, in terms of weight loss and reduced reproductive performance could cost about $13 a head for that animal. So these are important problems that limit the efficiency of productivity of our animals. So following on from Gary's discussion, we basically were Gary was kind enough to give us access to the Nimmitabel strain of blowfly, and we were really keen to see what the effect would be for producers in terms of this increased tolerance to seromazine and very mild cross-resistance to dicyclone. What does that mean in terms of the ability of these products to do their job in the field? And the level of protection that they afford for sheep against fly strike. So we conducted two studies. The first study was a larval implant study, which was conducted on sheep treated with either Vetrazin spray-on, which is a seromazine product that was developed about 30 years ago by Novartis, and CLiK, which is a dicyclonol-based spray-on product. And we used larvae from the Nimmitabel strain that Gary was kind enough to give us access to, but we also used a Vetrazin susceptible reference strain, so a strain that we know is able to be killed by these particular drugs as a control. So a larval implant study consists of applying product to the back of the sheep, either Vetrazin or CLiK, and you can see there that the treatment band is then marked on the back of the animal so that we can see where the product has been applied down the back of the animal. What we then do is actually make an artificial cut in the skin at some distance from the actual treatment band to stress that product as much as possible. We make an artificial nick in the skin and then place 100 first instar larvae onto the wool and then put a paper clamp over the top to allow those maggots to migrate down to the skin, and there's an artificial wound in there that they're able to get into, and we want to assess whether they're able to make a strike on that animal in the presence of that chemical. The chemical was applied at the lowest possible dose rate for that particular individual animal, so you would know when you look on the label of a lot of drums there'll be a dose rate, say, for animals from 51 to 60 kilos, and they've got the same dose rate. So therefore an animal that's 51 kilos might be getting the same dose as an animal that's 60 kilos. We wanted to stress this product as much as possible, so we erred on the lowest dose for that particular animal's weight. And we were assessing these larvae, these maggots, to see if they were able to initiate a strike every 12 hours. So the results of the larval implant study basically we showed that in the ceromazine treated group and the dicyclonol treated group, compared to the triazine susceptible strain, the control group that is, that both products performed in these larval implant study as per the label claim, independent of the strain used. So that is that the dicyclonol group was able to afford protection up to 18 weeks, which is the label claim for that particular product, 18 to 24 weeks. We stopped the trial at 18 weeks. The ceromazine spray-on treated group, those animals were afforded protection up until 11 weeks and beyond in some cases as well, which is outside the label claim of that particular product. So basically, in the larval implant study, this particular strain didn't seem to have any impact in terms of the length of protection. We conducted a field study though to see what was happening in the real world, what's going to be happening on farms, and what can producers expect from these products in light of Gary's findings. So we went back to the original property at Nimmitabel, and 385 lambs were treated with Vetrazin spray-on and 198 lambs were treated with CLiK. Obviously we're very interested in what's happening with Vetrazin because that was the most pertinent finding of Gary's work, but we also wanted to see what the ramifications would be for the CLiK treated animals as well. So these animals were treated by an experienced operator according to the label recommendations for these particular products, and they were continually monitored by the producer and Novartis as well, once every 4 weeks by Novartis, but continuously by the producer for the presence of strike. We also were able to record fly trap data, so we actually trapped flies to see the level of, or assess the level of fly pressure. So we want to make sure that there's actually flies challenging these products. We also looked at the DAG score, and these animals were particularly daggy. This is actually a photo of one of the treated animals. So they were suffering from a significant roundworm burden. So we collected DAG scores. And we also collected climate data just to see if the weather conditions were conducive to strikes being challenged on these animals. So the results, the weather data shows that there was significant rainfall during that particular fly season of 2011 and 12, as most of us would have experienced, and the temperature was conducive to having flies active, and certainly we would expect fly strike. In terms of the number of flies, we can see during the period of the trial, from its start here right out to 18 weeks when the study was concluded, that there was significant numbers of Lucilla cuprina, so that's the Australian green blowfly. There were significant numbers, particularly through where we would expect the ceromazine-based product to really be starting to become to its end of period of protection. So I guess the climate data and the fly trap data really gave us some good evidence that this was a significant challenge on these particular products. The results of the field study found that there was only one strike at 4 weeks in the Vetrazin treated group, and that was actually confined to the DAG. It didn't actually damage the skin on that particular animal, but there was no strike in either group, either the dicyclonol treated group or the ceromazine treated group, up to 14 weeks. And at 18 weeks, 5 lambs were found with breech strike in the Vetrazin treated group. But there was no strikes in the CLiK treated group right out till the trial was concluded at 18 weeks. And we can see that this data is just captured in another way. We can see that the number of strikes are recorded here. This is that one animal that was struck on the DAG, but again in the dicyclonol treated group. In the field study, we didn't find any strikes there at all. So what could we conclude then from this work that we've done both in the field and in the laboratory? We would say that against the field isolate that was discovered at Nimmitabel and found to have an increased tolerance to ceromazine and mild increased tolerance to dicyclonol in the laboratory, that this strain under both field and controlled laboratory conditions, that the products that we tested, that is CLiK spray-on and Vetrazin spray-on, maintain their registered period of protection. I guess what we could say then from that producers could continue to treat sheep with some degree of confidence, But it's really important that we continue to be very mindful of using these products correctly and not relying on chemical methods of control too much. And James mentioned Flyboss earlier, and really that is the key resource in terms of producers working out what the industry recommendations are for controlling fly strike. It's very important that we don't put excessive pressure on these chemicals if we want to keep having them to use in the future. So in terms of what to do, we need to use integrated pest management, chemical and non-chemical methods of control. And certainly it's important to not rely on one particular chemical too much, or one particular class of chemical with the same mode of action. And so, if we look on Flyboss, it's recommended to use a different chemical to treat fly-struck sheep as the chemical that you use to treat as a preventative. So, for example, you could use potentially ivermectin on struck sheep if you were using one of these insect growth regulators as your method of prevention. It's very important to also use a different chemical for both the control of fly and lice, as we saw in the case of diflubenzuron. But probably what's one of the really crucial points is when you're putting the product on, do it once and do it right. There's no point having to come back and having to reapply it or have protection breakdowns because you didn't put it on in the first place. And certainly the vast majority of problems I see with these sort of products when we investigate does really come back to application, and application is key. So moving on, we'll discuss or lead into the discussion about internal parasites. But before I start, just a show of hands. Who here is a recreational drencher? Does anyone here, drench in their spare time? Has it as a hobby? No? No one? I certainly don't enjoy it either. I'm from a property over at Harden, and I particularly don't like drenching pregnant crossbred ewes that stick their head down underneath the sheep in front of them. So we can say then that no one really is a recreational drencher in this room. But I think what you'll find based on the results of this anthelmintic resistance survey is that some of you, maybe unbeknownst to yourselves, might actually be recreational drenchers, in that we're using chemicals that aren't giving us the result that we're after. And it's often hard to tell with a woolly animal whether the product is actually working. But what we'll talk about this morning is a survey that we did of worm egg count reduction tests that were conducted between the 1st of January 2009 and the 30th of March 2012. And a worm egg count reduction test basically is where we test the animals before they're given a drench and get a fecal egg count, and then we test them after they've had a drench and get a fecal egg count, and then we determine what the level of reduction of that egg count is compared to an untreated control group for each particular class of anthelmintic. We'd also do that on the basis of the species of worm as well. So when we say that they have had larval differentiation conducted, that means that these samples were cultured in the lab and the worm species identified. And we would want at least 100 eggs per gram per species of worm that we're interested in. So if we think about the number of samples or submissions that we received, and this is based on submissions to government laboratories, private veterinarians, commercial laboratories as well, we received 394 submissions that satisfied the criteria, which we would say roughly on the back of an envelope calculation would represent potentially 2.5% of farmers, which poses the question if the industry sort of says that approximately 30% of farmers say they know their drench resistant status. I would say, well, how? How would you know if only 2.5% of farmers are seen to have done tests in this time period? I guess the other thing to be mindful of is that it's going to be biased. This data will be biased to people that have actually done worm egg count reduction tests. I don't know how it's biased, whether farmers that have better control methods and lower levels of drench resistance are the ones that are going to be doing worm egg count reduction tests, or whether the opposite would be true, where the farmers that have a serious problem are going to be the ones that are going to be doing worm egg count reduction tests. But this is the best, I guess, idea we've got of what's currently happening with drench resistance in Australia. So the results were quite alarming, and I know there's a lot of numbers on this particular slide, but I'll just go through and highlight what I feel is the more pertinent points. If we look at the older actives, the BZs, so they're the white drenches, levamisole, which would be the clear drenches, and naphthalifos, which would be OP class. We can see, if we look at the level of resistance, so these numbers represent the percentage of farms that have less than 95% efficacy. So that's less than a 95% reduction from pre-drench to post-drench, which is the industry and government accepted definition of an effective drench. So there has to be 95% or greater reduction. If we look at the percentage of farms that have less than 95% reduction, we can see that 96% of farms for both the whites and clears have a failure to reduce the fecal egg count by greater than or equal to 95%. There's 96% of properties that aren't achieving that level of efficacy. So that's quite staggering, and that's the definition of resistance. So on less than 5% of properties, we could say that one or more parasites will be resistant to the whites and clears. Okay. We also broke it down by worm species as well, but this column here will represent one or more parasites being resistant. Okay, so that's quite alarming. Certainly, if we look at some more contemporary type products, so the MLs, and they're listed here in terms of potency, in ivermectin, abamectin, and moxidectin. So moxidectin obviously being more potent than abamectin, which in turn is more potent than ivermectin. If we look at the results in terms of any parasite, so if there's resistance in one or more parasites, the percentage of properties that had resistance in one or more parasites to the MLs is quite alarming, as particularly when we look at moxidectin, which I would imagine many producers in this room would consider that a go-to anthelmintic. 54% of farms that were tested and involved in this survey had resistance to moxidectin in one or more species. 77% for abamectin and 87% for ivermectin. So that's really alarming in terms of the reliance on these chemicals is quite huge. Last year, 70% of doses that were given to sheep in this country were either contained an ML or had an ML as the sole active. So we're relying on this class of anthelmintic quite heavily, and it is showing significant signs of wear and tear. If we think about Barber's poleworm, and certainly maybe not as relevant here unless you have a particularly wet summer, but we've relied on levamisole and naphthalifos for many, many years, and they've been, I guess, niche products in some ways for Barber's poleworm. What we've found is that these products that had been effective for quite a number of years are actually showing signs of wear and tear as well, such that 30% of farms that were tested had levamisole resistance in Barber's poleworm, and 15% of farms that were tested had resistance in naphthalifos in Barber's poleworm. When we move on to the MLs or the mectins, the story is obviously a lot worse. Moxidectin, being the most potent of the MLs, was found to be resistant on more than half the farms that we tested or we had results for, which is quite staggering. The one interesting bit of data that we found that with Barber's pole, it doesn't necessarily seem to follow the trend in terms of potency. What I would argue is that this data is potentially skewed in that most of the Barber's pole samples we would get would be from the New England, and I think you'd struggle to find many farmers there that would actually use ivermectin in a Barber's pole season because they know it's so ineffective. So this change, I guess, in terms of the results for potency, the change from that trend is probably purely based on the numbers. Okay. For Trichostrongylus, so that's black scoureworm, and that's certainly an important parasite in this region. Traditionally, black scoureworm has been very susceptible to the mectins, to the MLs. These results, I think, have been mirrored in a number of similarly local surveys, both in the Hume and in the Lachlan, where we're finding increasing levels of resistance to the MLs in Trichostrongylus, where previously had never been seen before. The fact that 14% of properties that submitted samples for this survey had moxidectin resistance in Trichostrongylus is a serious cause for alarm, because this is something that's not really ever been seen before. Finally, small brown stomach worm, Telodosargia, which would be another important parasite in this region. We can see that the story is a little bit worse compared to the story for black scaleworm, in that with Osteotarsia, which is what this particular parasite used to be known as, there's significant issues with the MLs. 38% of properties had moxidectin resistance, 49% abamectin resistance, and 76% ivermectin resistance in Osteotarsia or Telodosargia. So there's a really important wake-up call for a lot of us about the products that we use, and certainly the way that we think about controlling worms on our farms needs to be reassessed. This just represents the data in a different format. So this is looking at, as a summary, the single actives across any species of parasite. So it lists the actives down here on this axis down the bottom, on the horizontal axis, and on the vertical axis it gives us an idea of the percentage of farms tested where the efficacy was less than 95%. And we can see that almost all the farms that were tested had BZ levamisole resistance in one or more species. And we can really see that trend in line with potency of the mectins or the MLs, in that moxidectin, certainly less farms compared to abamectin and less again compared to ivermectin. But moving forward, we would expect that trend to continue, in that this level will increase in line with the way abamectin has increased and the way ivermectin has increased since these particular anthelmintics were introduced. This is just another summary slide showing the scaleworms and comparing Telodosargia and Trichostrongylus. Again, really the take-home message for us, I think, is the level of ML resistance in Trichostrongylus, represented here by the orange colour. That's really important in terms of producers in this room, because when we think of, again, refer to that stat that 70% of doses contain an ML, we need to start thinking about preserving this active if we want to continue using it. And finally, for Barber's poll, looking at the actives along the bottom here and the percentage of farms that had resistance on the vertical axis, we can see that, again, particularly in this area, if there was a particularly wet summer, that we don't have a lot of options in terms of picking drenches that are going to be working, basically, and they're not going to have some degree of resistance. So we defined resistance as a product working, or an anthelmitic working at less than 95% efficacy. But certainly what we also looked at was the range of efficacy and what was the average efficacy you could expect from some of these products. And this is where, for mine, it becomes particularly alarming. So this graph represents basically the number or percentage of worm egg count reduction tests that fell into each of these ranges of efficacy. So the first would be 0 to 20% efficacy. So that's almost like drenching with water. The second is 21 to 40%. The third, 41 to 60. The fourth, 61 to 80. 81 to 94.9. And then 95 to 100 represented in orange. So without going through too much of the data, what we did then is calculate the average efficacy based on worm species. So, for example, for Telodosargia, or what used to be known as Osteotarsia, for the benzimidazoles, so the actives listed over here, the most common result that we found in terms of efficacy was 0 to 20%. So most farms that were included in this survey had an efficacy of 0 to 20% for the benzimidazoles against Telodosargia, or Osteotarsia, basically. If we look at levamisole, for the same species of worm, again, the most common result in terms of efficacy was 0 to 20%, which gives us an average efficacy of 50% for this particular active against Telodosargia. And for the benzimidazoles, 35% is about the average efficacy. So that's the average reduction you could expect from pre and post treatment in terms of egg count. So that's pretty staggering. If we look at the MLs, again, the story is not as bad, but this serves as a wake-up call, because the way things are progressing, we would expect the MLs to go down the same path. So against Telodosargia, if we look at moxidectin, so this is Osteotarsia here, the average efficacy is 81%. Okay, now if we think again about that study I referred to, the difference between a drench working at 85% efficacy and 99.9% efficacy is about $16 a head. Okay, so if your average efficacy is less than that, and your primary species at the time of treatment is Telodisargia, you can expect to lose $16 a head. Okay, so that's pretty important. 81% or 86% is not that great. It's not a great number in terms of the production losses that you'll find associated with that level of efficacy. For abamectin, the average efficacy against Homunculus, 46%. Against Trichostrongylus, 88%. Against Telodisargia or Osteotarsia, 76%. For moxidectin in those other species, still good levels of control against Trichostrongylus, but this number should really be higher based on the science that's out there. You know, Trichostrongylus that are resistant to moxidectin are considered quite rare. But against Homunculus, 83% efficacy with moxidectin. So again, if we're thinking about what we're going to select for our summer drench, and we're having a particularly wet summer, we might need to rethink our over-reliance on these MLs and maybe think outside the box a little bit about what we're going to use for our methods of control. So finally, just finishing up, we also looked at the combination drenches, and certainly the results are a lot better. It is a resistance mitigating strategy by putting single actives into combination for obvious reasons. They don't work synergistically necessarily, but there's much less chance of a worm having the genetics that's going to afford them resistance to 2 or 3 actives compared to one single active. So when we look at BZ naphthallophos and BZ parankylophos, the percentage of farms that had resistance in any parasite would be 74% for the BZ and the older OP, but for the newer OP, slightly less, and that would talk to the difference in potency between those two OPs. When we look at the more recent combinations, so the BZ, the white clear ML and the white clear ML with Closantel, certainly in terms of producers selecting a product that might work, the product that had the lowest prevalence of resistance would be the BZ levamisole abamectin. In terms of the combinations, that would be the product that would have the lowest prevalence of resistance compared to the BZ levamisole ivermectin, and that would talk to the potency of those particular MLs. Certainly the 4-way combination, where these results pretty much all came from the New England area of New South Wales, where is predominantly a Barber's Pole region. It was quite staggering to see 4-way resistance on 44% of the properties that were tested. And admittedly, this is a small number of farms just from the New England where drench resistance is a serious issue. But that is quite staggering, the 4-way resistance on 44% of properties that we've had involved in this survey. So what does this mean? What are the take-home messages? Well, when we're drenching sheep, we need to drench to maximise productivity and minimise resistance. And I think most of us would probably previously be erring more towards the former and without considering the latter, and that's minimising resistance. If you rely on the older drench classes, including the MLs, we need to aim to preserve them whilst maintaining productivity. And how do we do that? Well, here's a few ideas. Certainly all this information is captured on WormBoss as well, and I'd certainly urge a lot of you to go and have a look. But worm egg count reduction tests every 2 to 3 years are imperative to know the drench resistance status of your farm and to know what's going to work on your particular property. Otherwise, you might be drenching recreationally, which I find fairly boring. Effective quarantine drenching, so using products that you know are going to work when you buy sheep in, so that you're not buying in someone else's resistant worms, which is probably the quickest way to get drench resistance onto your property. We need to have a plan when we're selecting our drenches. And when we're talking about those strategic drenches that we know are going to happen every year, so first summer drench, second summer drench, weaning drenches, we need to have a plan of within season rotation of different classes of anthelmintic. So that's not just changing the colour of the drum, it's about actually looking at the label and seeing what the actives are that are in that particular product. Use older actives in combination to make sure that we're mitigating resistance as much as possible. And finally, try and consider incorporating new actives that are available in rotation now. because they will remove the pressure on those older classes, particularly the MLs, and it will help to prolong the life of those particular drenches for as long as possible. And certainly there's a whole lot of data that's come out of Murdoch University in WA looking at computer modelling situations where looking at rotation of different actives, and the best choice was to use new actives in combination with, or in rotation with, triple active combinations as a way of mitigating resistance. And they can't help you while they're sitting on the shelf. So we need to start thinking about getting them into the rotation and into the plan as soon as possible. And finally, as you'll probably discuss in the workshops this afternoon, check the efficacy of your drenches 10 to 14 days after giving a short-acting drench, just to see and get a rough idea of what's working on your farm. Okay, thank you.
Okay, thanks Ben.